Hello, we are going to talk about a monopoly today. So we are going to start with a single good, which is an ordinary good, which means it respects the law of demand. The price goes up, the aggregated demand goes down, the price goes down, the demand goes up, okay? So it's downward sloping. Doesn't need to be a straight line, but it's a downward sloping curve. The derivative of the price with respect to the quantity is negative, or the other way around. The demand goes down when the price goes up. Okay? So we are going to focus on this part here of the demand. Okay? We know the demand continues here. If the price is above this, the demand is zero. But we're going to ignore this part, right? Why? Because we want to have a one-to-one relation between prices and quantity, okay? So along this bit here, for each price there's a single quantity, for each quantity there's a single price. For instance, for this quantity here, Q0, we have this price P0. For this price P0, we have this quantity P0. And along this bit here, it's a one-to-one relation. So we can think about the inverse function. Okay? We can think about the inverse function. And we're going to use this so that we study the monopoly problem. Single price monopoly, a monopoly is a firm that has the whole market. There's only firm in the market, and the monopoly will choose the price or the quantity. So pi here is a notation for the profit of the monopoly. So pi is a function of quantity, but we can also express pi as a function of the price. Okay? So the monopoly has infinite market power. It has all the market power. It can choose exactly what's going to be the price in the market, or it can choose exactly how many units it's going to sell in this market. Okay? So you can express the profit as a function of quantity or price, exploring the fact that the demand here, we are focusing only on the part of the demand from here to here, and we are ignoring the higher prices. The higher prices anyway would be not very clever choice for the monopoly. If the monopoly chooses a price above this level, nobody's going to buy the product, right? The monopoly cannot make a positive profit in this case anyway. Now, profit of a monopoly, I'm plotting here on the vertical, pi, the profit of the monopoly, as a function of the quantity, okay? As a function of the quantity. And as I just explained, the monopoly can choose the quantity. For each choice of quantity, there's a unique price that will lead to that quantity and vice versa. It's a one-to-one relation. This point here in red is the point is associated with this particular choice. Q star is the choice that maximizes the profit of the monopoly. Among all these points on the curve, on the profit curve, the highest possible is this point here. So if the monopoly is very smart and choose this Q star here, it maximizes, it makes this profit level pi star. It's the maximized profit of the monopoly. Okay? But potentially the monopoly could make other choices, not so clever choices. For instance, the monopoly could choose the quantity equals to 0. It's this green point here, and it loses a bit of a fixed cost. So quantity 0, the price has to be very high, okay? If the quantity here is 0, the price has to be this high here. Remember, we are ignoring higher prices, okay? So this would be this point. The other polar extreme would be choose this point here, Q upper bar in blue, this quantity here, Q upper bar, and it's associated with 0 price. Okay, so it would be this point here in the demand curve. A very large quantity, you satiate, you exhaust all the demand, you charge 0 price, and everybody who wants the good can get it for free. But for the monopoly, it loses money if it makes this choice, right? You have negative profit here. At this point here, if you choose Q positive, right, Q plus, the monopoly is making positive profit, not as much as Q star, but positive profit. Now in this part of the curve here, the monopoly has a positive marginal profit. That means that the derivative of the profit function with respect to the quantity evaluated at this point is positive. What is this derivative? It's the marginal profit. Okay? Marginal profit is the derivative of the profit with respect to the quantity. It measures the instantaneous rate of change of the profit when you increase the quantity by 1 unit. So at this point here, the monopoly sits down and thinks, what if I push my price down so that my quantity, consumers will buy 1 more unit of the good? Is this a good idea? And because this is positive here, it is a good idea. If you do this, the monopoly increases its profit. Okay? So at points that have this property here, such that the marginal profit is positive, you should increase your quantity. So you decrease your price a little bit so your quantity goes up and you're going to increase your profit. This point here, the other way around, Q minus, you have negative marginal profit. Okay? So your marginal profit here is negative. I could write this equation as pi prime of Q minus is negative. Sometimes we use this prime notation, sometimes we use this. This is called line bits notation for the derivatives. This one is pi prime of Q plus is positive. Okay? So this here says, if you are to increase your quantity, if you are already choosing this quantity, and you increase your quantity a little bit, your profit goes down. You move from here to a point here. Okay? So your total profit goes down. It's not a very clever idea. So if your marginal profit is negative, you should actually decrease the quantity. You should charge a higher price so your quantity will go down so that your profit will go up. If the monopoly wants to maximize its profits, that's what the monopolist will be doing. Will not choose this, will choose the Q star, the maximum. Okay? So in general, the profit of the monopoly equals total revenue minus total cost. Okay? R for revenue, C for total cost. Revenue is how much money the monopoly gets from consumers. C is the cost that it needs to spend. And these three variables are functions of how many units it's going to produce, Q. So taking the derivatives, you're going to have marginal profit equals marginal revenue minus marginal cost. At this point here, that maximizes the profit, Q star, right? This slope of this tangent line here is 0. So your marginal profit is 0. Therefore, another way to write that is that your marginal profit at Q0 is 0. Okay? So if you're maximizing your profit, your marginal profit is 0. It means that your marginal revenue is equal to your marginal cost. What about if we are here at this point? Well, your marginal profit is positive. This means that your marginal revenue here is above your marginal cost at this point here. Okay? Or another way to write that is that your marginal profit is positive at this point here. Here at this point, at Q minus, the other way around. At this point, your marginal profit is negative, which means your marginal revenue, it's going to be smaller than your marginal cost. Okay? At this part of the curve here. So if you are to increase your quantity, you're going to make less money. You're going to lose more money because the change in cost will be bigger than the change in revenue, and you're going to end up in a worse situation. While if you're here, the increase in revenue will be bigger than the increase in cost, and you're going to be better off. if you increase the quantity starting from this point. Okay? So mathematically, the derivatives are looking at this tangent line. For instance, the derivative of the profit function, the marginal profit calculated at this point, it's the slope of this angle here. It's the tangent of this angle. It's the instantaneous rate of change of the profit with respect to the quantity. If you are to increase the quantity by 1 unit, by how many units your profit will go up or down. And if you calculate here, you move a little bit more, you increase. While if you are here and you increase your quantity, your profit goes down. So this angle here is negative, and the tangent of this negative angle will be a negative number. The derivative is the tangent of this angle. So the derivative calculated at this q minus is the tangent of this angle, which is negative. Okay? So remember, in general, the derivative calculated at any point will be the limit when h goes to 0 of the profit calculated at q0 plus h minus p of q0 over h. Right? The derivative of the profit, that's the marginal profit. Okay? So if you're maximizing your profit, your marginal profit is 0. If your marginal profit is positive, you should produce more quantity. And if your marginal profit is negative, you should produce less quantity. Okay? See you next time. Bye bye.